I'm a production designer, and the field I work in is called art direction, which nobody ever understands. Um, I'm responsible for all the visual aspects of a film or a stage play, and I work closely with the director to conceive of all the visual concepts of the production. And we work together, we choose locations together. I'm in charge of the art department, and I supervise the design of all the sets, interiors, exteriors, whether they're real or fantasy. People ask me, where do you get your ideas from? What are the things that inspire you? And so I want to try and answer those questions by showing you an example of a project that's personal to myself, that isn't actually associated with production design. And it's a project that started some years ago that was actually originated by my son when he was 8. And so I'll start at the very, very beginning. I have to get used to this. So this image here is of my parents, taken in 1953 with my sister. And I was born the following year, which was the very last year of rationing in England after the Second World War, so it's some 10 years later after the war was over. You see here in the picture my father, who was he was a consulting engineer, and I'll speak a little more about his work later, and my mother, who at this point was a homemaker and avid sewer. And in this picture, she's actually wearing one of her very carefully tailored outfits that she would often put together. In fact, she would also take me when I was little out shopping with her, and we would go and choose the fabric together and also the patterns that she was going to purchase. And I would help her choose which one she wanted and so forth. When she got them home, she would lay the fabric out on the dining room table and very carefully pin the very thin tissue paper patterns to the fabric, and then cut them out and sew them together and form the outfit. And of course, this process completely fascinated me. It seemed very strange and mysterious, but that you could turn one thing into something else. But I guess in some ways this was the beginning for me. My father, on the other hand, he worked in London for a company of consulting engineers. And he would do very similar things. He'd bring home huge plans, blueprints of various projects they were working on at that time. And I'd see them very often again at home, laid out. And by the time I was the age of 10, he would take me often to see various building sites that were the projects that they were working on. And I would accompany him and wear the hard hat, which I liked doing, with all the other men on the building site. And we'd stand around in the mud and the cold, and I would listen to my dad talking about reinforced concrete and things that I didn't understand at that point, which I sort of absorbed and enjoyed, I suppose. But as I grew up, I began to really become sort of attached to the process of drawing and building things, perhaps inevitably, and eventually ended up at art school where I started stage design. And part of what we did there was to study the history of costume and ornament as well, as a sort of background to our work for the design for the stage. And this would lead us often, or be taken to the Victoria and Albert Museum in London, where we would choose an object to draw. And in the very classical kind of way, we would sit on little stools, groups of us, around the object we'd chosen, and study it and draw it so that we understood the period by copying the line and the style of each thing. And because I guess I'd seen these paper patterns turned into the body form so often, I personally was attracted to the armor. And you see here on the left side, this is a steel European armor of about 1530, and the one on the right here was actually built in Greenwich for Henry VIII. This is 1515. Anyway, at this point I'm going to jump forward to really what I'm here to talk about. That was all just background. When my son was 8, he asked me to build him a knight's helmet. And I think this is what he had in mind, so that he could play knights in armor. And let's take this. So I built him something very simple. It was a crude idea, and basically I formed a cylinder and for him to wear, something like this, and cut it so that there were 5 panels at the top that would join together to form a dome shape. And it was a very simple concept. He was very satisfied with this, and I think it was an afternoon amusement. But anyway, he liked this thing, and he wore it again and again, and it got beaten up, and he would ask me to repair it, and I'd repair it with tape until it fell apart. And then I'd have to make another one, and then that one would fall apart, thank you, and I would make yet another one. And as this kept happening, the idea began to get stuck in my mind that, in fact, I felt like I'd sort of come up with something that was not only very simple, but that needed to be sort of developed in some way. So I started to think about other forms of armor and started to look at exoskeletons in general. And this is a picture of a Japanese beetle here, which has a wonderful set of armor. And the more I looked into it, the more I discovered and learnt about the insect armor. And of course, it's exoskeleton, which means that it's the external skeleton which not only protects the creature, but also supports the internal body, which has no other, only the organs inside. The material that it's made of is called chitin, and it's a rather remarkable material. And in fact, it takes different forms. It's actually related to what's the cellulose actually in plants. Actually, it's a related form of cellulose anyway, even though it's not actually the same substance. It's very flexible and takes different thicknesses and different hardnesses as well. And when I saw this, I thought, what I need is something that really has a similar kind of characteristic. And in fact, I came across a material that is called polypropylene, and that's what we make Tupperware out of, and bottles of dish liquid and pill bottles and things like that. But I continued to look at this idea of the exoskeleton, and of course it exists in other forms, entirely different from insects. In architecture, there's so many different ways that this concept has been experimented with. This is a pavilion that's made of a very flexible membrane material that's been tailored to fit over a framework. And of course, when that's done, it creates this sort of taut skin, which makes the form very, very stable. And there are other examples, of course, like the wonderful roof structure. This is the Savile Building, which is in the Great Windsor Park in the UK. This was designed by 2 architects, Glenn Howells and Burrow Happold. Very difficult names to say. And this structure is referred to as a sort of as a grid form underneath, and then there's this wonderful waveform on the top. And the combination of these shapes makes it very, very stable and very, very strong, considering how thin it is. And in fact, you can see in the top picture that the structure is supported by these quadrupod legs, but the overall roof is over 90 meters in length. It's quite a wonderful structure. I'm going to go on to these sculptures, which visually look disconnected from what I'm talking about, but they have an interesting concept. These are sculptures by an artist called Kenneth Snelson, and he was a student of Buckminster Fuller. And they independently, but also Snelson went on to develop it further, this concept of transegrity, which is what this is called. And the word comes from 2 other words, tensional integrity, that's where it comes from. And it tries to describe what's going on here in the structure. They're interesting because the concept here is that the bars or the sort of forms inside are actually continually under compression, and they exist within a sort of network of cables which are under tension. So the two concepts, they kind of balance each other out in the form. And in fact, as you can see in the top picture, this is probably Snelson actually installing this sculpture in the Netherlands. You can see they're extremely stable, unbelievably so. And it's a concept that actually exists in nature in many ways as well, so we're discovering. Another form of it would be a balloon. As you sort of blow air or force air into a balloon, the pressure of the air is expanding the balloon, but of course the skin of the balloon is pushing down on the air, so it creates this sort of balance within the object. And this is the same concept that exists within cell walls and other natural forms. Something different again, these very interesting little structures, these are skating huts that were built by some architects called Packed Cow Architects. They're in Vancouver in Canada. And these were skating shelters set up in Winnipeg. And they are built of a very, very thin plywood, 2 layers of very, very thin plywood that is stressed again. The shape is cut, and then it's joined, pinned together, very similar to the approach I was taking to the helmet. And these are beautiful structures and extremely durable, even though they're very, very lightweight. So with these ideas in mind, I felt that it was necessary, and I, of course, with my own interest in the sort of style of helmets and armor, I went on to create a little more involved new prototypes. And initially, I started to make them in paper, and then eventually in the polypropylene. And they started to be very strong and durable, even though they were only pinned in a limited number of places. And it meant that you could, well, Sebastian, my son, was growing up by this time, and he wasn't really playing with them, but he used to sort of experiment with them and sort of sit on them and squash them, and then they would bounce back out again. And this sort of quality that they had, I thought was very, very interesting. So I went further and decided to make other versions of them. But it required doing a lot of prototyping. And in the process of cutting the shapes, which I would do quite spontaneously out of paper initially, I would cut the shape that I felt would fit together, and I'd get roughly what I was looking for. And then I would take it apart and scan it on the computer, and then work the geometry of the object that was scanned backwards. So I would figure out from the perimeter of the object where that line was stemming from. So it meant that if I needed to make adjustments to the pattern, I could always find the root of the shape. So it was a sort of very backwards way of finding the geometry. And it meant that often there were these lines that would stretch out from the drawing that would sometimes they seemed that they would go into infinity. But it kind of created a kind of phantom geometry around what was essentially a flat shape that was going to become a three-dimensional shape. And then as I worked further with these, and they were cut in the polypropylene, obviously each step made them more sophisticated and they became more precise. And I tried to make them as beautiful and as sort of reminiscent of the original forms as possible. These are some other ones. This is the finished item here. And in this process, the way they snapped together became very, very important. At first, I was using these sort of plastic pins as a quick way of doing it, but then I realized it was kind of fun to be able to put them together and then take them apart again. So it was really turning into a sort of construction system, which I was not really expecting. So I started to adapt these existing snap fasteners, and as you can see, the shapes got very interesting. And all of these elements are flat. They're entirely flat patterns. And this one is a Roman helmet, and the next one is a Norman helmet, and so they go on and on. And this last one is a samurai helmet, all made in a very, very similar way. You can see underneath here that the samurai, of course, what is interesting about the way they would form the sort of dome shape at the back is it's made of these sort of concentric sort of sphere sections, which are actually quite difficult to figure out. And of course, for all the help that the computer gives me, it doesn't figure out the problem for me. I still have to figure out the actual geometry. These, in the end, were the source of an idea that was very simple and then became more complex. And then the more people that looked at them, I was encouraged really to take them as far as I could. And I'm going to show you a couple of more recent ones. I went back to the concept of the exoskeleton, of course, and these are some insects that I'm playing around with still at the moment. And they're, of course, much more complex. You can see they're sitting on the drawing of all the components that go into one insect. And there's actually a diagram of these little connecting pieces, which you can see, which I'm now using as a sort of format that joins all the other articles together as well. So they can begin to be interchangeable. It's developed into a kind of Lego system, if you like, and which I recently took to London to display at the London Design Week, which was last September. And we had a very successful 4 days showing them for the first time to the public, which I'd never done before. They'd only existed in my studio. And we had a really great reception, and I felt that it was time to sort of really try and launch it and take this idea as far as I possibly could, which sort of brings me to the wobbly houses, I suppose. Finally, I realized, of course, that the material itself, the polypropylene, is kind of interesting. It's a material that's very good to recycle because it recycles very well. You can have a very, very high percentage of the old material in the new material. You can get the same characteristics out of something that's been recycled many times. It can also be added to or introduced to other materials as well, so you can sort of sandwich it between other things like Kevlar or what have you, other things like that, other hard materials. Anyway, I have a clip at the end here which I want to show you, which is quite brief. This gives an idea of the way people were responding to them. We had no instructions and no encouragement from us, and people really just jumped in and really had some fun with it. And we realized, of course, that it's actually a very intuitive process because you're recognizing the object, and even though it's a puzzle and a new way of thinking about a puzzle, it's kind of fun. And it's also like sort of snapping bubble wrap while you're doing it. So my plan is to continue with it, and you can see I've still stuck to and all ages of people enjoy this. It's fun. We had young ones and older ones all having a pretty good time with it. So I plan now to attempt to get into the manufacturing of them, which is a little more complex than one would think, actually, because it requires the development of certain machinery that can, even though the system is very simple, it means that the machine has to know exactly where it's going. And although this is a process that exists for other machinery, I have to be able to tie certain machines together that up to this point have not been put together. So thank you very much.